An audio control panel, or ACP, is installed at the captain, first officer, and first observer stations. Through use of the ACP, a crew member may transmit and receive from the flight interphone, cabin service interphone, passenger address system, as well as the VHF and HF radios. The ACP also allows a pilot to monitor voice and identification audio from certain navigation aids, such as an ADF radio. The ACP provides a means to control receiver volume and microphone selection. Additionally, a volume control is installed on the cockpit speakers. Only one radio at a time can be selected to transmit, but multiple radios may be received. Pressing a mic select switch down will engage the selected radio for transmission and cause all other mic switches to pop up to the off position. The selected mic switch illuminates. The pilot can select to receive on multiple radios. The system volume switches are levers. Raise the lever to increase volume. The push-to-talk switch can be used to key a boom mic or oxygen mask mic that is in use. Selection of the boom mic or oxygen mask mic is made by the two-position toggle switch. Notice the location of the other push-to-talk switches. The voice range switch is common to other aircraft. In the voice position, station identifiers are filtered, and only voice transmissions can be heard. In the both position, both voice and station identifiers are available. In the range position, only station identifiers can be heard, and voice is filtered out. A rocker switch on each pilot's control wheel can be used to transmit. Moving the rocker switch in one direction activates the push-to-talk feature of the radio that is selected for transmission on the ACP. Moving the rocker switch in the other direction activates the push-to-talk feature of the flight interphone. Use of the flight interphone position of this rocker switch allows the pilot to transmit on the flight interphone regardless of the selections on the ACP. Each pilot station is equipped with a handheld microphone. The microphone is equipped with a push-to-talk switch that activates transmission over the radio that is selected to transmit on the ACP. Radio communication through use of the very high frequency, or VHF radios, is provided by a left, center, or right VHF radio. The center radio is controlled by the ACARS. The left and right radio frequency is selected by a dedicated panel for the left and right radios. Each control panel allows the selection of two independent frequencies by use of the transfer switch. The active frequency light illuminates for the selected frequency. Control of voice transmission and receiver monitoring is provided by the audio control panels. There is no control panel for the center VHF. The center VHF is used by the ACARS. The ACARS provides automatic tuning to this radio to a standard data line frequency that is used for ACARS data transmissions. Are located at the left and right VHF communication radio control panels are located at the aft aisle stand. Each control panel is used to tune the communication frequency for the respective radio. There are two frequency indicator windows on each panel. One window is selected as the active window, which makes the other window inactive. Selection is made by use of the transfer switch. The active window is indicated by the illumination of the associated control light. Dual level knobs are used to select a frequency for the respective window above the knobs. The outer select knob selects the 3 left digits of the window, while the inner select knob is used to select the 2 right digits. Range communications between the high-frequency or HF radios provide long-range communications between the aircraft and a ground station or between aircraft. There is only one antenna for both HF radios. It is located inside the leading edge of the vertical stabilizer. Both radios may receive at the same time. However, if one radio is transmitting, the other radio is cut out from operation. The off position removes power from the unit. The frequency is selected by 2 selector knobs. Rotation of the left knob changes the digits to the left of the decimal point. Rotation of the right knob changes the digits to the right of the decimal point. The USB position, or upper sideband, allows the radio to transmit and receive on the high side of the frequency. The AM position, or amplitude modulation, allows the radio to transmit and receive on the selected frequency, but the radio signal is accompanied by a carrier wave. The antenna must be tuned before transmitting. The antenna is automatically tuned after a frequency change is selected when the pilot presses the push-to-talk switch on the microphone. Press the mic key to begin the antenna tuning process. The antenna tuning process will take several seconds. A tone will be heard through the cockpit speakers or through the headset while the antenna is tuning. When the tone stops, normal communication is available. Detection and alert of wind shear conditions. The need for early detection and alert of wind shear conditions is obvious in the airline industry. The delay of proper response and the lack of wind shear detection was cited as a causal factor in a number of takeoff and landing crashes. The FAA is currently improving the recognition of wind shear conditions by the installation of low-level wind shear alerting systems, or LWAS, at various airports. In addition, the FAA determined that an onboard recognition system would be helpful to flight crews. To this end, FAR 121.358 was born. It requires that U.S. commercial aircraft with over 19 passenger seats be equipped with a wind shear detection system. Specifically, FAR 121.358 requires that airlines install an airborne wind shear warning and flight guidance system, an approved airborne detection and avoidance system, or an approved combination of these systems. Let's review some general information about microbursts and wind shear conditions. A microburst is a downdraft that is typically 700 to 3,000 feet across. The velocity of the downdraft is usually between 40 and 110 knots. This airflow mushrooms out as it hits the ground, causing the wind energy to flow in all directions. Approaching the microburst may produce a positive component, usually over 40 knots velocity. In the center, your aircraft experiences the downdraft energy. On the other side of the microburst, your aircraft will experience a tailwind component of 40 knots or more. One common type of onboard recognition system is the reactive wind shear system. A reactive system detects wind shear conditions by monitoring the performance of the aircraft and issues cockpit warnings and flight director guidance after the aircraft is detected to be within a wind shear environment. The 767 GPWS provides reactive wind shear warnings below 1,500 feet radio altitude when the aircraft is currently in a wind shear condition. For takeoff, the system becomes active upon rotation. The reactive system provides aural alerts in the form of a two-tone siren and wind shear voice. The reactive system also provides visual alerts in the form of a red wind shear annunciation on the attitude director indicators or primary flight displays, illuminated master warning lights, a wind shear light on the instrument panel. Although a reactive system is helpful by providing detection and guidance, it does nothing to prevent the entrance into the wind shear. After the crash of a DC-9 in North Carolina that was equipped with a reactive wind shear detection and guidance system, the need for prediction and early warning of wind shear conditions was apparent. A predictive wind shear detection system, or PWS, provides detection of wind shear in front of the aircraft during the takeoff and landing phases of flight. The predictive wind shear system operates automatically and is transparent to the flight crew unless a wind shear event occurs. Some aircraft have a reactive system, others have a predictive system, and some aircraft have both types installed. This frame provides an overview of the features of reactive and predictive systems. The reactive system provides detection alert when an aircraft flies through wind shear conditions and then provides flight director guidance to optimize the recovery maneuver. The forward-looking predictive system provides detection alerts before entering the wind shear condition. The alerts are provided as cautions or warnings. Thus, a pilot has the information necessary to avoid dangerous weather before it is encountered. If a wind shear is unintentionally encountered, the flight crew will use the standard wind shear recovery procedure as listed in the flight manual. How does a predictive system operate? Recall the weather radar emits short, intense pulses of microwave energy which are returned by reflection. The reflected signals are received and processed to determine the intensity, bearing, and distance to the targets. This system provides reliable return for water droplets, water-covered hail, and terrain mapping. Other conditions that cause wind shear are not detected by this system. The weather radar has an advanced microprocessor design, which allows it to use the Doppler concept to detect areas of moderate and high-level turbulence, as well as low-level wind shear, microburst. Again, the detection requires that some level of moisture or particulate matter is present in the atmosphere. Other types of wind shear must be detected by the crew as they apply their knowledge and experience for traditional wind shear avoidance methods. The detection of wind shear conditions is accomplished by detecting the Doppler shift of the horizontal wind component. The detection system is able to detect the velocity of droplets coming at your aircraft and compares this to the velocity of droplets moving away from your aircraft. The velocity level of these approaching and departing droplets determines the level of alert. It is assumed that the horizontal speed of the droplets is a direct indication of the intensity of the downdraft. The weather radar automatically begins scanning for wind shear when 1. The thrust levers are set for takeoff, or 2. The aircraft is in flight below 2,300 feet radio altitude. The PWS alerts are available approximately 12 seconds after the radar begins scanning for wind shear. Note, even though the system scans for wind shear below 2,300 feet radio altitude, the predictive wind shear alerts are only issued below 1,200 feet radio altitude. If desired, the pilot can enable wind shear alerts prior to takeoff by pushing the weather switch on the EFIS control panel. If wind shear is not detected, only weather radar returns will show after pressing the switch. If the weather radar is on, each radar sweep alternates between a weather sweep and a wind shear sweep. This alternate scan may delay the update of your weather display by up to 12 seconds. The pilot-selected tilt is operative during the weather radar portion of the sweep. However, automatic tilt is applied during the wind shear detection portion of the sweep. This frame shows the PWS alert area that is available on the ground prior to takeoff. The range is 3 nautical miles, and it begins 0.5 nautical miles in front of the aircraft. Notice the 25-degree arc for the caution range and the area for warnings that is provided. Now we also show the in-flight PWS alert area. The dimensions are similar, but the warning area extends only to 1.5 nautical miles. During takeoff and landing, new PWS alerts are inhibited during critical phases. Specifically, any new caution alerts are inhibited between 80 knots and 400 feet radio altitude, and new warning alerts are inhibited between 100 knots and 50 feet radio altitude. These inhibits do not remove existing PWS alerts. Let's describe the levels of wind shear detection alert that are provided for takeoff and landing. The lowest alert level is the wind shear caution. It is available during takeoff and approach below 1,200 feet radio altitude. It is delivered when wind shear is detected within 3 miles ahead. It is delivered by an amber wind shear message on the HSI or ND, a red wind shear symbol on the HSI or ND, and an oral alert of Monitor Radar Display. The symbol can display only if the HSI or ND mode is Approach, VOR, Map, or Center Map, and the terrain switch is not pushed. The highest alert level is the wind shear warning. It's delivered by the symbol display, the wind shear light, a red wind shear message on the PFDs and NDs, the illuminated master warning lights, and specific oral warnings of wind shear ahead or go around wind shear ahead. As you can see on this frame, the oral warnings differ for warnings on the ground or in flight. Wind shear warnings are available when below 1,200 feet AGL. A warning is delivered when wind shear is detected within 3 miles ahead if you're on the ground and 1.5 miles ahead if you're airborne. A wind shear warning indicates a wind shear is within 1/4 nautical mile laterally either side of your heading. Specific company policies are in effect for crew response to a PWS advisory. These policies govern operation prior to takeoff, during takeoff and climb out, and during approach. You should know that GPWS alerts have priority over PWS alerts, and both GPWS and PWS have priority over TCAS alerts. For safety purposes, ground personnel should remain beyond the red area shown here to avoid the U.S. government standard radiation level of 10 milliwatts per square centimeter. The maximum permissible exposure level boundary is approximately 13.4 feet from the radar antenna center at approximately a 240-degree arc. Recall that microwave energy is also transmitted when the weather radar is turned on. Pilots must ensure that both the weather radar, the transponder, and PWS be turned to the off or standby position before approaching the gate area. Now let's answer some questions.